I'm John Golia.
And I'm Greg Fife. And we are
the Flight Safety Detectives.
We're just two guys who have spent most of their career with the National Transportation Safety Board investigating aircraft disasters and aviation safety issues all over the world.
Yep, and this podcast is where we talk about everything from accidents, airplane technology, to the big business of aviation.
We live and breathe aviation. My co-host John has been in the aviation business for more than 60 years. He was the first and only airframe and power plant mechanic to get a presidential appointment to the National Transportation Safety Board.
And Greg is a former air safety investigator and GO team captain for the NTSB. He's investigated everything that flies worldwide since he started his career 40 years ago. And on top of that, he is a Living Legends of Aviation inductee.
So between John and myself, we have over 100 years of aviation safety experience. It's time to buckle up because it's going to be wheels up. Let's get this show in the air.
Well, hello, John. Welcome to another episode of Flight Safety Detectives. Part of the broadcast is coming from my Maryland office, where it is extremely noisy because of the 60 billion cicada that are right outside my door, making all sorts of noise. I'll tell you, John, I got in last night to D.C., came home, woke up this morning. I thought we were under attack. There was a strange noise. I walk out, and a lot of the trees in the front yard are infested with these little buggers that are making one heck of a lot of noise. I don't know how it is up in the Boston area, but it sure is noisy down here.
Well, I haven't heard them up here yet.
Yeah, well, I'm going to send them your way.
Gee, thanks.
Yeah, well, I'll tell you, they are noisy, and I just happened to look at some of the trees in the yard, and they are lined up wall to wall, chewing on leaves and bark and everything else. I mean, it's nuts, man. No matter where you walk, I ran this morning, no matter where you are, they're dive bombing into you. You're stepping on them. I mean, it's crazy. Can't wait for them to all go away and quiet to return. So
yeah, go away and come back again in 17 years.
Yeah, really. I'll tell you what. You know, we talk about, birds creating a problem. It's a good thing that these little buggers don't fly in a flock or a group or whatever. You ingest a bunch of these things, they're going to make a mess. But, oh, well, it is one of those things. But I am going to revert back to some of the things you and I talked about in a couple of previous podcasts regarding airport etiquette. Of course, I know you're traveling, and I've picked up my travel immensely. I've been traveling a lot. And with more people coming back into the mix and traveling by air, not only has the rage against flight attendants increased, which, I mean, I just am at a loss for words. But it goes along with the fact that we've lost this airport etiquette. I dealt with idiots yesterday coming in that, I'll tell you, one, now that they're back, they all think that they are privileged and they want to be the first on the airplane and they want to get on and think that airplane's going to leave without them and they'll push through. I mean, they were loading folks with disabilities. And there were two clowns that decided that they were special. They didn't have a disability, but they decided that they were going to go on with the disabled folks because they wanted extra time. Put their bag in the overhead, and I'm glad that the gate agent trap lined them and basically made them stand in a corner with a dunce cap on. I mean, where is the etiquette? I mean, we've lost it. I mean, the civility is somewhat gone now. And it is disheartening, but it's also a safety issue, especially given the fact that in the recent past, a Southwest flight attendant lost some teeth in a battle with a woman who just was belligerent and refused to follow federal regulations. This is just uncalled for. And I don't know why all of a sudden. I mean, I know that people are frustrated. This pandemic has really changed, a lifestyle for some. And I just don't know, John, where the civility is with these people. I mean, it's driving me nuts. I was fortunate again, to be able to continue working during the pandemic last year, which required me to travel. And it was really nice when I was about the only one on the airplane and about the only one in the airport. Now the airports are crowded, and attitudes, I just do not understand how people can be so belligerent, so rude, so callous to other people, especially some folks that are disabled. It's like, what gives you the special right and privilege? And then, of course, the abuse of not only gate agents and ticket agents, but especially flight attendants. That is just totally uncalled for. And I know that the FAA has pushed it. You and I have talked about it on this show. I think these people need to go to jail for 5 years minimum. Let them sit there and think about how stupid they were, besides costing them a lot of money. And the fact that with a federal offense and sitting in jail, they aren't going to work in a decent job anymore because of their stupidity. I don't know, John. It's just, it's out of control. And I don't know what the magic answer is to get it back. I mean, flying is still, a privilege. It is not a right. And people need to respect the fact that, hey, they're dealing with other people that are working for a living. And, you don't, I mean, if this is the way you treat family members and friends, then man, you need to be out on an island, because I sure as hell won't tolerate it if somebody starts getting in the face of a flight attendant or a ticket agent. I mean, that's just uncalled for.
Yeah, you see it all the time. And I've actually started to gather a bunch of these cases together to do a podcast on it. So let's plan on doing the next podcast. We'll cover this rage issue.
Yeah, because it's a safety of flight issue.
Without a doubt.
And these are the kinds of things that might even be difficult for the NTSB. God forbid we have an accident where something goes on in the back of the airplane. It's carried forward, and we've got an issue, and the crew loses the aircraft. I mean, we may not know what was transpiring in the back completely. We don't have any voice recorders back there. We sure don't have any video cameras back there. And I know that those two issues are a topic of discussion as well. I mean, I hate to see that we're going to have to start recording what's going on in the passenger cabin because of all these idiots. So, well, I'm glad I'm glad you're collecting the data, and we're definitely going to talk about this, because this is just shameful, besides irritating. I just, every time I go to the airport and I watch the way people act, this is not a civilized society when people are doing stupid things like that. It's uncalled for, and it's just sad. Given the fact that we are talking about accidents and the potential for accidents, today we're going to dissect an accident that became very famous, unfortunately. May 25th, 1979, we lost a DC10, American Airlines Flight 191, coming out of Chicago. I was just coming to work for the NTSB while the board was in the midst of doing this investigation, and ended up having a great discussion with then Woody Driver, who was the vice chairman of the NTSB. And if you research this particular accident, you see some of the pictures. There's a famous picture of Woody holding up the bolt, and everybody called it the magic bolt and the suspect bolt and the cause of the accident. And that was a famous picture of him holding that bolt up for the press. And I know that you, of course, know a lot about this particular event, John, and given the fact that it was related to maintenance and the processes that were employed by American Airlines, but also a couple of other carriers. So I think that this will be a great little case study to educate the audience, because there's been a lot of discussion about it, and of course it did change the way the FAA oversees maintenance procedures for an air carrier. There is of course a discussion about maintenance procedures and what latitude a carrier does have in being able to develop procedures that are more efficient and things like that. I think that this is a perfect opportunity for the audience to hear some things, John, that I know that you'd never read in a blue cover report by the NTSB or someone's article. So I'm ready to get rolling because I want to hear what you have to say about this, since you know some of the players, you definitely know the process. So I'm interested on your take of this particular event.
All right, I am too. This was a major maintenance failure, and it led to a number of changes, but also there was a few changes that were never made. But before we get going, I need to remind everybody that this podcast is being brought to you by PAMA, the Professional Aviation Maintenance Association, as well as Avemco Insurance. Avemco Insurance has been insuring general aviation airplanes for years and years, and they've even insured Greg, which may be called their judgment into question.
Yeah, I mean, I tried to lay off the abuse of you, and I know you're in attack mode, so...
Yeah, well, I know, but you're going to lay off for 30 seconds, and you're going to be back, so I'm going to get my licks in early.
Yeah, there you go.
So if you need insurance, you need to renew your insurance. If you're buying a new airplane, you need insurance. Give Avemco a call, 888-879-0389, or online at avemco.com. And if you tell them you just listen to the Flight Safety Detectives, you'll get a 5% discount just for listening. So that's not too shabby. Today's cost of aviation is high and going higher, and 5% is 5%. It's better in your pocket to help offset some of the cost of flying.
I'm hoping to get up to Avemco the next time I come to DC in a 3 weeks and hang out and possibly even do a show. So we should definitely be talking to the audience from one of our main sponsors. And I think that they'll learn a lot because we intend to educate when we go up there. So thank you, Avemco, for sponsoring our show. And I know that they like me because I'm kind of a stellar customer. Unlike you, John, where, you know what, your insurance rates might be a little higher, not because of your skills or lack thereof, but, being almost as old as dirt, I think they have an issue with that.
There is no age restriction on insurance. All right, so let's get into my favorite subject. I actually had a lot of research done on this accident. So it's really interesting that we're going to get to do this today. Now, the airplane was a typical DC-10 flight coming out of Chicago, like you said, in May. And it had been in maintenance in Chicago, actually, not just the day before. I think it was something like 10 days before this accident. The airplane had been in, and it had the engine removed so that they could get in behind the engine mounts, and work on a spherical bearing, they call it. They needed to be replaced because there was a manufacturing problem.
Was that replacement of that spherical bearing mandated? Was there an AD or service bulletin or...
Service bulletin. All right, so it was as a result of a service bulletin. Now, one of the problems, we got to go back a little bit. One of the problems that came up with the design of the DC-10 was engine changes that were unduly complicated. It was almost like we took a step backwards in design philosophy with these engines because, what we call today quick engine changes, QEC, are just that. The engine and its mounting hardware is designed to make replacement of the engine easy and quick. I can tell you on the DC-9, which is the next airplane before the DC-10, the airplane before it, we could change that engine in under 4 hours. 4 guys, under 4 hours, start to finish. Wow. Right. On a good day, to change a wing-mounted engine on this airplane, the DC-10, was 24 hours on a good day. All you had to do was run into some problems, and those hours start to tick up pretty close. And the tail engine was 72 hours. So the airlines wanted to get that done more expeditiously, and there was a lot of pressure to do just that.
Let me just stop you right there, John, real quick. I mean, when a manufacturer is designing an aircraft, they go to the airlines and they go, hey, what kind of airplane do you want? what are your needs, this, that, and the other. Don't they get into the maintenance side of it and take input from the airlines? I mean, the manufacturers already know what they need to do from a maintenance standpoint, but don't they get input so that they can find the most expeditious way to maintain critical parts or large parts like engines and that kind of stuff, so that they don't have to reinvent the wheel later on? They can design it right now.
Well, that's true. And I can go all the way back into the 60s and remember how United Airlines had people at Boeing, and I have to assume that they had them at Douglas as well, during the development of the airplanes for that purpose. But it may very well be that this one got away from them, or it obviously got away from them, because it was really an untenable situation to have engine changes that took the airplane out of service for that period of time. And when I'm giving you that period of time, I'm talking about in a facility that's set up to do engine changes. If you get an unscheduled engine change out in the field, which in the 80s was not uncommon, you could be talking about losing this airplane's, being out of service for a week. Mm. So it's, and it costs multiple thousands of dollars every hour the airplane's on the ground. So over and above the maintenance cost, the loss of utilization of the airplane skyrockets the cost. So that was the driving force behind trying to find a faster way to replace the engines. And this was an American Airlines accident, but Continental Airlines at the time had developed this procedure that was not recommended by the manufacturer. It was not in the manual. When the airlines queried the manufacturer did not approve of replacing this engine and pylon the way it was supposed to be done. Now, the problem with this is, let's talk a minute about why it was a problem. All right. The pylon is the piece of metal that looks like an arm that hangs out from the wing and connects to the top of the engine. That pylon is a very complicated piece of engineering. You have this great big engine running out there, and the way I like to explain it to people is, you got this big engine and it's spinning at thousands of RPM. And what happens if you run out of oil? The oil pump fails, run out of oil, or a passageway gets clogged. And all of a sudden you seize a bearing in that motor that's running. This great big fan has so much mass to it as it's spinning around. If you were to stop that quickly, it has the ability to actually break the wing. So the way the manufacturer gets around that failure mode is by designing the pylon to break. So this little device that looks like an arm coming out from the wing is designed to fail in such a way that it won't jeopardize the airplane. And typically the way it fails is the pylon will break in such a way, it's sequence breaking. It'll break in such a way that the engine will go up and over the wing. It doesn't drop down. It goes up and over the wing, so it doesn't damage anything. And in this case, that's exactly what happened, but for a different reason. The engine didn't seize. We actually had a pylon that was compromised because of the procedures that maintenance was using to change this engine. And they were using it in a facility, and they were using a forklift to do it, which is in this case, very difficult method to do, because when you line the forklift up with the engine and you hoist the engine, take the load off of it, you don't know if you've got the load centered or not. So if the forklift happens to be positioned wrong, or if any of the attaching hardware, the forklift itself, doesn't attach directly to the engine, there's some tools, fixtures that are attached to the engine, and then the forklift is attached to the fixtures.
We're talking how much? I mean, how much does that engine weigh?
I think it's about 14,000 pounds.
So, I mean, that hydraulically operated forklift not only has to be positioned correctly, but of course you have to maintain the proper hydraulic pressure to raise that 13,000 to 14,000 pounds and then hold it in place for a period of time.
Yes.
Correct?
Yeah. Normally what you do is after you get it connected, you will start lifting it until the airplane starts to go up just a little bit. and then maybe you adjust it back. You just want to get it so it's suspending the weight and taking the load off the mounts. Now, the way the engine was designed to be changed was right up in the lower end of the pylon where it attaches to the engine. There's connections in there for the fuel, electrical connections, in and out. The generator sending electricity out to the airplane to power the airplane. A hydraulic pump that's sending hydraulic fluid to the airplane to run all the systems that run hydraulically. And you've got a whole bunch of wiring that goes in to control the engine operation as well. So it's a very busy place inside that pylon. And therein lies the problem, because it's very tight. You don't have room in there to swing a wrench. Some places it's hardly room enough for you to get your hand in there. And you've got all these cannon plugs, electrical plugs to disconnect and then reconnect, the fuel lines, and some pneumatic lines as well, airlines, pressurized airlines, high temperature. So that means they're thick and their clamps are sturdy. So it's very difficult, and that's where all the time is consumed. Well, apparently Continental Airlines figured out that the connections further back on that pylon, where it attaches to the wing, are much, much easier to access and much easier to disconnect. So they developed a process where you disconnected the pylon from the wing and lowered it with the engine, and then made the change to that pylon to the new engine on the ground. And that 14,000 pound engine plus, I'm not sure how much a pylon weighs, but it's certainly 500 plus pounds. All that weight off the airplane is a challenge for the forklift if it's not positioned properly, and there's no guidance whatsoever on how to position it when you're doing this task. And when you go to put it back up on the airplane, it also causes a problem on the attachments, because you're now attaching things where it's a very tight fit. When you're attaching the engine to the pylon, it was designed to have room around it, room to wiggle, so to speak, so that you can position the engine and attach the bolts to hold it in place. But the pylon was never designed to have that kind of flexibility. It's very tight tolerance. And now you're trying to put 14,000 plus pounds, move it around to get it lined up, and it can be a problem. And sometimes it's easier to line up the back part of the pylon before the front. Well, the problem with that is the back of the pylon, where it attaches to the wing, is not as robust as the front of the pylon is where it attaches to the wing. So now that causes additional problems, because once you attach it and you start to move it around, you're actually stressing the rear portion of the pylon. And that's exactly what happened in this case. And it also happened in several others that we found out after this accident, when the word went out to everybody to check their pylons if they're using this procedure. And there was a number of them that came back with cracks. So this was a ticking time bomb waiting to have another accident. Fortunately, the NTSB got in front of it and figured it out early. But the chain of events inside the hangar is also very interesting and very telling.
From the stuff that I've read and know about, because I was with the board when they were doing this investigation, and got wind of this, that, and the other as I was roaming the halls for a while, they ended up having to shim that pylon. Is that pylon not normally shimmed? I mean, is it flush mounted? And if they had to use a shim, should that have been a giveaway to these guys that, hey, something's not right?
Well, in this generation of airplanes, there was shims all over the place. So I would suspect that it was not an unusual occurrence. What made this event more troublesome for everybody involved is, we say it, and I said it, we call it a maintenance accident. But there was also an engineer on the floor who I happen to know very well. And he was sort of guiding this effort. And the problem with some of that is that an engineer can't accomplish maintenance, but he can write a maintenance program. It's the way the FAA has got this set up, that the engineer really doesn't have the background and skills that the mechanic has to do the work, but he has the ability to use data and design a process. And so Joe was here to make sure this job got done the way it needed to and design a process. By a process, I mean paper, procedures, step by step on what you're going to do. And because there was none, it was sort of on the fly with everybody. And most mechanics, when they work with engineers, and I've done this for a long time, so I've noticed it from myself and from others, is they'll do whatever the engineer says because the engineer is the guy who writes the procedures anyway.
Now, when that engineer writes those procedures, are those procedures vetted by anybody before they're approved?
Yes, internally, and they'll send them to the manufacturer. And typically, if the manufacturer agrees with it, they'll say no objections to it, or some verbiage to indicate that they don't have an objection. Or they'll come back and say they disagree. And that's what they did with Continental with this procedure. They came back and said they disagree. They don't approve it. However, under the aviation rules, the Federal Aviation Act, air carriers, 121 carriers, and actually 135s as well. So big airlines and commuter airlines have the ability to write their own procedures. Normally, they follow closely to what the manufacturer has done, but not always. And in this case, they planned on writing their own procedure that was going to be different than the manufacturer's approved procedure. And that's why they were proceeding with this. So in the course of they're doing this work, they have no procedures, so there's no procedures to follow. And so they made the replacement. They pulled the engine down, replaced the bearings, and then put it back up. In the efforts to hook the engine up, on this particular case, the mounts on the rear lined up first. So they hooked up the mounts in the rear. And as I said just a moment ago, they are very close-fitting, tight tolerance. And now when you start to move the engine around, because remember it's positioned on a forklift, it's not perfectly lined up. There's lots of variability in there. And it wasn't lining up automatically, so they had to move the forklift, and guys would push on the engine because there's always a little bit of give, and push on the engine to get the front mounts to line up. What they didn't know was that they were actually cracking the rear mount as they did that. But it was, cracks can be very small to start with, and then over time they grow rather rapidly. They got the front mounts finally installed, and they hooked up all the connections, the hydraulics and pneumatic and electrical connections, and now they're good to go. And they put the airplane back in service. But when they put it back in service, it had these cracks on the rear of the mount. Now, the problem with that cracking in the rear of the mount, that is an area of maximum stress on takeoff. So stop and think about it. You got this engine sitting out in front of the wing. You got this pylon or arm hanging out, holding that engine, and all of a sudden you advance the power. So what happens? The engine pushes forward. Well, because it's out on the arm, it not only pushes forward, it pushes up. So it's flexing the pylon at its attach points on the wing.
And of course, you got the rotational torque.
Correct. So you've got both factors acting upon this two attach points on the back of the pylon on the wing. And now you have a compromise with a little crack. Well, little cracks get big when you put them under load. And that's what happened in this one. They really progressed pretty quickly because there was only 10 days between when the work was done and when this event occurred. So it really progressed quickly.
Good morning, you're on the ground, Canadian 920. We're just coming up to Alpha Juliet.
So let's set the folks up then with the airplane comes out of maintenance, it's returned to service. Everybody believes it's good to go. Here we go. Now, was there any kind of evidence? I thought I read somewhere where there was some evidence that the mechanics that were doing this had some issues in actually mounting that engine. It was more difficult than they thought. And didn't they leave that forklift unattended for a while and the engine dropped a little bit?
That's correct. The hydraulics on the forklift were not the best condition. Forklift was well used and had a lot of years on it, and it did sag, especially if you turn the engine off. So the hydraulic pump stopped providing back pressure on the lines. It actually would leak down a little bit, and they had that problem as well. And again, it boils back down to the fact that there were no procedures in place, written procedures to accomplish this task. So they were essentially winging it, which is something all mechanics, wherever they are, industry, automotive, aviation, they're pretty handy with their hands and can find ways to do things that most people never thought of, including engineers. Therein lies some of the problems that we get in the industry, and especially in this case, because they've got a can-do attitude. We can get this done. We don't need the paperwork. We got an engineer here. He's going to tell us what to do. And, remember 24 hours for typical engine change. So what you have here, you're not going to have a mechanic on duty for 24 hours. So you might have him on duty for 12 hours, and then some other mechanics are going to come in and take his place. But he's not going to do 24 hours. Even if he does 16, there's still going to be another crew to come in behind him to pick up this work. So it's a lot of different hands in the soup, so to speak, trying to get this job done. And not everybody thinks the same, and not everybody has the same level of understanding of what they're doing. So you've got all these variables in there that are clearly just setting everybody up for failure in this.
So now this airplane goes to the gate. Everything is, apparent that it's good to go. They load 258 people and a crew of 13 on this aircraft, and they push off. And the cockpit voice recorder is kind of benign. They're going through all their routine procedures and checklist calls and that kind of thing. They taxi out, and they're getting ready for takeoff. Everything appears to be normal. There's no indication of any kind of engine issue. They line up and they push the power up. And according to both the flight data recorder and the cockpit voice recorder, that jive as far as the sequencing of data and cooperation between the data on both the FDR and the CVR. As they accelerate down the runway, everything appears to be normal, except that something is happening out there during the takeoff roll. They rotate on speed. They accelerate immediately through VR, which is the rotation speed. V2 which is their go speed. That means they're committed to flight. But the one thing that the board talked about that wasn't really in line with the procedures that the pilots were utilizing was that they rotated the aircraft at a slower rate than normal. They were, according to the FDR data, they were rotating at 1.5 degrees per second. And the operations manager for the airplane, according to American Airlines, was more like 3 to 4 degrees per second, which doesn't sound like anything in the grand scheme of things, except the fact that they had rotated at a slower rate. Of course, the pitch attitude was about 14 degrees. And as they were initially climbing out is when they lost this engine. I mean, almost immediately, right after liftoff, the number one engine pylon fails and the engine separates.
Right. The engine was found on the airport, so right adjacent to the runway. So it really happened right at liftoff, approximately.
And in fact, that's what made Woody Driver famous, because they were walking the runway looking for shrapnel and things like that. And that's where they actually found that famous bolt that he ended up holding up for the news media. They found it on the runway.
Yes. I'd like to talk a little bit about what happens now with that engine. First off, the flight crew. Why don't you tell everybody what a flight crew, when they get an indication of engine failure, what happens? And why is it different with this one?
Sure. So in this particular instance, the crew, the only thing they have available to them is instrumentation in the cockpit. They can't look out the window and actually see the engines back on the wing. They have no visibility back there. So they are relying on engine indications and system indications to let them know what failed, whether it's number one, number two, or number three engine, and then associated systems. And it immediately became evident to them that they had what they believed was an engine failure. Now, the failure, they thought it was, an operational issue where the engine stopped producing thrust. They did not know that the engine actually left the aircraft. And so in reviewing all of the instrumentation, they knew it. And according to the flight data recorder information and the board, the first officer was the flying pilot on this particular event because the captain's flight director was in op. And of course, they typically use the flight director command bars as their pitch reference during rotation and initial climb. So they deduced that because the first officer's flight director was still operational, he was likely the flying pilot because he was flying the airplane after they identified what they believed was an engine failure. He was following American Airlines procedures almost to the letter. And that'll come back later on in the investigation to not be necessarily correct, nor the procedure that should have been followed to salvage this bad situation. But he's flying the airplane. They had accelerated to their V2 speed plus 6 knots, and they were at about 10 to 14 degrees nose up. Problem is that what they didn't know, because of the system failures, when that engine separated, of course, it ripped the pylon and as you talked about, John, the associated system. So you had the fuel lines, you had the hydraulic lines, you had pneumatic lines, and of course you had cabling. The problem is that the slats, the leading edge devices on this airplane, as well as the spoilers on top of the wing, are hydraulically operated. And they are locked in place, or at least held in place, with hydraulic pressure. And when they lost the engine and they bled all that hydraulic pressure, the slats that were in the position for initial takeoff, again, little did they know that they had a asymmetrical slat retraction. That is, the slats on the left side, since it was the number one engine that left the aircraft, those slats retracted. And again, the crew felt the yaw. It was corrected, but they didn't know the asymmetrical slat issue because the cabling and the wires for the indicator in the cockpit had been damaged. So they didn't have reliable information in which to fly the airplane. And again, they just thought they had a normal engine failure and flew the airplane per the train procedures. And it wasn't until getting into the investigation and having, I think they did, I can't remember how many different flight crews, but they flew like 50, 60, 70 flights in the simulator, flying profiles based on the flight data recorder. And everyone that flew unbeknownst to them and flew the procedures as they were trained ended up in the same situation as the accident flight crew. And it was later determined that because they didn't have excess speed, because they had an inadvertent slat retraction on the left wing, which again caused an aerodynamic issue and caused the left wing to stall, it wasn't controllable at that particular speed. If they had excessive speed, instead of flying it at V2 plus 10 or thereabouts, in this case, I think they're V2 plus 6 knots, there wasn't sufficient excess energy to overcome that left wing stall, and the aircraft started rolling to the left almost immediately. Despite the corrective actions, the first officer, who was the flying pilot, was unable to effect an efficient recovery before ground impact.
Well, to add to the flight crew members' load is the fact that we lost this 14,000 pounds plus engine on takeoff on one side of the airplane. So immediately you're going to have an unbalanced condition. And I'm sure that most of our listeners know that weight and balance on an airplane is critical Where we put the fuel, where we put the cargo, where we put the passengers is critical. I mean, I've been on many flights where the flight attendants on light loads had to come up and move everybody either to the front of the airplane or to the back of the airplane to get it in proper balance condition. And losing 14,000 pounds on one side of the airplane suddenly is a great big surprise to the crew. And then add to it the slats retracting, leading edge devices retracting. It just adds to the problem, complicates it one after the other. And he had absolutely no time to deal. Even the voice recorder only had, I believe, one word on it.
Well, yeah, because as soon as the engine pylon failed, the CVR and FDR shut down. There was no usable information after that. So they were able to stitch together the data that they did have, look for trends, and develop a scenario that resulted in the crew losing control of the aircraft, and of course subsequent recommendations for changing some of the operational procedures that were both trained and exist in the flight manual about losing an engine. And it was interesting because when the board was doing this investigation, they looked at other airline procedures, the airlines flying the DC-10, as well as the military. And it was of interest that American Airlines engine out procedures were different than other airlines and the military, who were all operating the DC-10. American Airlines procedures were somewhat unique. And one of the recommendations that came out of the board was for them to standardize to what these other folks had in their particular AFMs and standardize those engine out procedures.
Yeah, there's a few other interesting things with this pylon that came to light. You know, different airlines use different procedures. And United Airlines used an overhead crane. They did not use the forklift method. And as such, they didn't have any cracked pylons to the extent that Continental and American did. And memory says that there was also some foreign carriers that had problems as well with cracks.
And if I remember right, John, right after the accident, of course, now this was one of those accidents, if I'm not mistaken, where a friend of ours, who at the time was the administrator of the FAA, had to make a decision about whether or not to ground these airplanes.
Yes, not a good place to be.
And what was the outcome of that?
They pulled the certificate on this airplane. They pulled the type certificate on this airplane, which means they all go to ground, regardless of where they are. You know, typically, an AD note against a U.S. airplane may or may not have to be picked up by a foreign authority. So, for example, the British CAA, if we issue a maintenance alert, something must be done before further flight, they don't have to follow that. They can follow their own reasoning. The only thing that reaches this airplane worldwide is pulling the type data certificate, which is the airworthiness certificate, means the airplane is safe to fly. By pulling that, and that's a big deal, that's not to be taken lightly. So the administrator really just was way out there and pulled the certificate from this airplane, and that meant every one of these airplanes operating around the world is now on the ground. As soon as it lands, it's done.
And with that, I know that they then went in and inspected. That's when the inspections took place of the pylons, and that's where they were finding other cracked pylons or the attach points for those pylons. Now, in an effort to be factually correct, because that's what you and I are about on this show, the flight safety detectives, we believe in accuracy, I was able to locate some very good information. The fact that the pylon and engine together weigh 13,477 pounds, the fact that that engine sits 9 feet forward of the attachment point. So in our interest to be exact, I was able to get you exact numbers.
Well, my 14,000 pound estimate wasn't far off. That was memory, too.
You got lucky.
Yeah, probably did.
You got lucky.
I probably did.
But sometimes it's better to be lucky than good.
All right, so another noteworthy event in this sequence here is that, remember I said Continental started this procedure. They were the first one. They also discovered 2 cracked pylons after they had used this procedure on their airplanes. And both of those procedures, when those finds, so it's what we usually call them, FIND, apostrophe S, when you find something of significance, it's supposed to be reported to the FAA. Continental did not report it to the FAA.
That's really interesting in the fact that they didn't disclose that. And again, where was the FAA? I mean, okay, they had some engineering. They had to have known that Douglas had said, we don't support this procedure. The FAA had to know that, even though the airlines were using something that wasn't endorsed by the manufacturer.
You know, one of the things that I've long believed with the structure of the FAA is they're not really structured to do this detective work. So all the action, if you will, around American Airlines takes place in Dallas. That's where the main FAA office is, and everything else is run by outside, separate offices, separate reporting change. So it's almost like each one of them is their own individual island in this country. And Continental's was in Houston. So the FAA in Houston would have the Continental information. You get this information bubbling up, but the FAA, even to this day, doesn't do a great job of cross-pollinating that information on a timely basis. Now, today we do have reporting systems. Once a year, everybody gets together, usually in Texas on I think it's February, where they do the ASAP meetings and they share all this data. But it's still leaves a lot to be desired on coordination for this information getting back and forth. And sometimes the airlines say, you know, if we develop a new procedure for an engine change, that's an economic issue, and it gives us a competitive advantage. We don't want to share it with our competition. So you got all these tug-of-wars going on, and the FAA is stuck in the middle of it. Also, all during this time anyway, the FAA would almost never be found on midnights shift. And of course, that's where some of this work started. When I was working midnights, I used to plead with the local FAA office to have somebody come by at 4 or 5 o'clock in the morning, come in to work early, and just come by, just to have a presence. I was never successful with that. Never, because the local office would never see the width and breadth of the work that we were doing in Boston, so they would never know what was going on. They'd come into the hangar after all the airplanes were gone, and they'd look at paper, but they wouldn't see the airplane. You know, and it's easy to criticize the FAA on this and many other events, but it's a difficult job for them to do in this complicated area. Maintenance support in flight standards is only a fraction of the flight deck support in flight standards. So everything is pilot-centric in the FAA on this air carrier business. It's all pilot-centric, and maintenance personnel within the FAA don't get the resources they need to do the oversight that they should be doing. Now, what the FAA is hoping today to accomplish is to use safety management systems, SMS, to make up for some of that lack of presence on the part of FAA inspectors. School's still out on whether or not that's going to work or not. I believe it can work if it's done right, but you're hard-pressed to find carriers today that are doing it right. There's every one of them has taken their own approach, and there's areas in which there is holes or less than perfect processes.
Now, I remember the problem caused the FAA did get whacked a little bit by the board for not having proper surveillance and reporting systems like you were talking about, because these issues had taken place at other carriers. There wasn't a good repository of information. And I know that the board also tweaked them for failing to disseminate particular information to carriers that were operating this aircraft to these issues. What else came out of this? Was there a design change?
Oh, there certainly was. Interestingly enough, flying big airplanes today, let's leave the 787 off the table. But flying big airplanes today, there's two basic philosophies. Airbus uses fly-by-wire, electrical wire, to fly the airplanes. So you've got electrical signals driven by a computer going out to the flight controls, and they'll move whichever way the computer tells them to move. Boeing's philosophy up through the 777 has been an actual wire, 7x19 stainless steel wire that you actually, the pilot, when he pulls back on the control yoke, the column, will actually drive a wire back to move that control. It also is moving it hydraulically, but in the event of a hydraulic failure on a Boeing airplane, the cable can also fly it.
So you have manual redundancy.
Manual redundancy.
To an electronic system.
Right. And also, in some of the areas on the Boeing airplanes, from the beginning, they actually had hydraulic fuses. So if you had a failure like they had here, with the engine coming disconnected, the flow of hydraulic fluid would be much faster through the system. They had already determined what the flow rate for a normal system would be, and when it went faster, it would shut off that hydraulic system at that point, and that would prevent the leak from going any further. So we did not have that on the DC10, and even after this accident, and they put the hydraulic fuses in the wing on these engines, my memory says they also put some on the engine in the tail, but right up close to the engine in the tail. The tail still had 4 hydraulic systems, which is what this airplane had, came together in one place on the Sioux City crash. And when that engine went boom, it severed all 4 of those lines. And again, all the hydraulic fluid left the airplane, and now the flight crew is left with no control. So there's 2 different, actually at this time, there's 3 different philosophies on flight controls for airplanes, with Airbus being fly-by-wire, Boeing being fly-by 7x19 wire, which is control cable, and Douglas being all hydraulics. Now, there's weight savings involved here. There's lots of reasons why you do that. You can do it, but there wasn't enough safeguards on it. So to that regard, this DC-10 at this point in time was probably much like the 737 MAX 2 years ago, where suddenly we found out that we missed in certification a lot of things that should have been picked up.
And I remember the board talking about that, and I'm trying to think of the words they used. They were talking about a system that wasn't tolerant of operational failures and something like that, because one, nobody ever thought the engine was coming off, but there was an intolerance to a failure like this, and that procedures didn't accurately reflect. Because the DC-10, this is not the first time an engine has actually left an airplane, John.
Right. No, there's many cases of that.
I mean, 727, I remember, I think it was even American. It was an American 727 over New Mexico or Arizona that lost an engine, and a few others.
Yeah, National Airlines lost one. It's not uncommon. They've had these failures before. 737-200 or 100 or 200 had a failure out of Philadelphia on an airplane, I remember. The rear mount in that case, the bolt had broken, and that engine left the airplane. And again, that engine went over the top of the wing and fell away from the airplane as designed, and there was no problem, and the crew was able to turn around and land it.
And if I remember right, the board in its analysis also talked about that had the crew been able to keep speed up, have excess speed like we talked about, beyond V2 plus 10, which is that minimum speed that they want the pilots flying at. If it had excess speed, there is a probability. They didn't say high probability, but they just said a probability that the crew may have been able to remain in control of the aircraft and get it around. But again, without really knowing the extent of the damage out there, the situation that they were dealing with, and things like that, they could have been more successful than they were, but they may have lost the airplane trying to make an approach back in, because they're going to have to slow the airplane down and try and configure it. And that could have created problems. So I think these are the lessons that for not only the airlines, but operators of any kind of airplane, even if it's Cessna 172, is really understanding the controllability of your aircraft and knowing that if you solve it on one end of the flight, you may have a reoccurrence of it on another end of the flight. Because, you pick up the speed, you fly the airplane, everything feels good, but then you have to slow it down because you got to get it back on the ground. And maybe this is, the beginning of an opportunity where these are not out of the realm, John. Losing an engine like this, kind of like getting stick shaker right at rotation, indicating a stall, whether the airplane is actually stalling or it's a bad stall warning system. These are the kinds of scenarios that should be, of course, incorporated into pilot training to begin with. Throwing these, they don't have to be a recurrent training thing, but, just something to test a crew's ability to recognize and then, of course, hand fly the aircraft, because they're going to have the tactile feeling. You don't just turn the autopilot on and think it's going to handle it all.
Yeah, the things that were missed in the certification process. And I think we'd be remiss if we didn't remind people that certifying an airplane is an incredibly, incredibly difficult process. And when you see things are missed in certification, it's because of that process being so difficult. It's so time-consuming, so expensive, and it's just, you're asking people to look for needles in haystacks with a blindfold on. It's very difficult, and one of my criticisms of this airplane was there was no mechanical locks on the slat actuators, which we mentioned retracted and caused the wing to stall ultimately. Most other airplanes in this time frame that were certified had mechanical locks on the actuator. So once they were extended, they were locked in place, and it took hydraulic pressure to unlock them. But this one didn't. It relied upon hydraulic pressure to keep them in place. But once you have proved that, once the FAA proved that, and the manufacturer decided to go that way, then where is the what if hydraulic system fails? Oh, maybe we need to have a fail-safe on here. Maybe we need to have a hydraulic flow limit or a fuse to cut the hydraulic fluid off to keep this thing locked in the event that there's a problem with hydraulics. So I remember, it's an interesting side story here. I remember hearing from Boeing a long time ago, probably in the 80s. I have a lot of friends that work for Boeing. And the story goes something like, when they were designing the 747 in the latter half of the 60s, the board of Boeing was just beside themselves with an airplane this big, carrying this number of passengers, if there was something wrong and they lost the airplane, which at that time, the size of the passenger load was nothing near what the 747s ultimately could carry. But they supposedly put together their own what-if team that went behind the design people and said, what if you get a failure here? What if this fails? Causing people to think. That's a derivative of a safety management system, because an effective safety management system would ask those kinds of questions and force people to think about the consequences of whatever it is they're looking at.
And you bring up a good point, John. The question is, what if this what-if board used that methodology with the 737 MAX?
Yes, they would have found it. Not only that methodology, there's an engineer who left Boeing a few months ago out of the certification office who was known throughout the industry, throughout the FAA, and I even heard about him at the NTSB, who was unbelievably good at ferreting out issues like this and issues like the MAX had. And unfortunately, the FAA, in their wisdom, did not have him on the certification of the MAX. But they brought him in when they looked at it again after everybody got their hands slapped with 2 accidents. They brought him in, and recently I was told that he was the one that found the vast majority of the oversights that were made by the original team.
I'd be interested that if we have any FAA folks or manufacturing folks that listen to the show to send us an email and let us know if a what-if board actually still exists or does exist in their respective organizations. Because again, I think that, the engineers can only engineer and look at it so many different ways. And a lot of these issues don't come up until in-flight, in-service flights. We see this a lot. And that's why the airplanes are always being changed, tweaked. That's why a certain block of serial numbers is different than another certain block of serial numbers, because improvements have been made through in-service use, failures, abnormal operations, whatever. And I'm wondering if a what-if board shouldn't be required, if it isn't now in some form or fashion, should be required as part of the manufacturing/certification process.
Well, I don't think we're going to see it in that exact form, but what we're going to see, and there's a lot of pressure right now for manufacturers to have a safety management system. And there was just some press just within the last week about Boeing and the latest $17 or $19 million fine that was not related to the MAX, but covered those airplanes. It was unapproved parts in the cockpit.
Yeah.
So, they paid a fine, but they're again being pushed by the FAA for a safety management system, but not fully. I don't know why the FAA is not just saying, adopt the rule like they have for the 121 carriers and say, this is it. You need to comply.
Yeah. I mean, we're seeing it filter down into airports and every other aspect of aviation. So that should be at least a standardized regulation that you operate in aviation. You have to have some sort of safety management system, even if you're manufacturing just a component part, because, these failures, I know that the regulation talks about operational use and failure rates of 10 to the minus ninth and that kind of stuff. But I think that it should be more formalized myself. The other thing I think is that these manufacturers, the Boeings, the Airbuses, the Cessnas, Pipers, Beech, whatever, on their board of directors, they should actually have some people, not somebody that's been in a management position that thinks they have safety background, but in fact, people that have been down in the trenches that understand safety as part of their board of directors so that they can look down. I think that if Boeing had had somebody that was really safety oriented, hands-on safety oriented on the board of directors and is familiar with what's going on the manufacturing floor, and then of course in operation, talking to the respective flight safety department or whatever, they may have had a different view of what was going on with the MAX and some of the other issues that are now going on with the 777X, and of course the quality control issues of the 787. How are these things getting by not only lower level management, upper level management, executive management, and even the board of directors? Is nobody looking?
They're not understanding what's going on the floor. Europeans, even with the Airbus having somebody from their labor force on their board of directors, Airbus, it's still not robust enough. They need to have a real working safety person that's on the floor that does come up for those meetings, and one that is around ferreting out the information from what's going on the floor, because it's not invisible. I mean, there's people I know in South Carolina, I know of at least 4 people, including a couple of which were managers, that have quit or become whistleblowers because of what they were seeing during the assembly of the 787s down there. So when you get a big company and you go through multiple layers before you get up to the big decision makers, things get filtered out. Things get missing. In fact, when I first went to the board, and for years, right around the time I first went to the board, I had a line I used to use, and that was that I had never given credit for the maintenance management on how they could keep all the dirty laundry inside the hangar And in those rare cases where they had to bring outsiders into the hangar, they would take them into the hangar, march them double time right through the hangar and out the back door, and not let them see enough of the operation to identify the problems that were going on. That's what a robust SMS system will give them, is a good insight. And that's what Nick Sabatini tried to get into the FAA, and he wasn't there long enough to finish that task, and I don't know where it is today. But he had his version of SMS in there where the inspectors could filter things up to him. But obviously, since he's gone and we had these problems with the MAX, it wasn't coming up to them, given the fact that there was a number of inspectors out in Seattle who had problems with this airplane, were trying to raise them within the chain, and they never got up to the decision makers.
Well, I know that we've had a great show talking about this, and you provide a lot of insight from the maintenance perspective. In closing out our discussion, John, is there anything in the backstory and the shadows that you and I always talk about with every accident? Is there anything that people, our listeners, would never see in the report about any of the players that were involved? Because you know a lot of these folks and the operations and that kind of thing. Are there any things that you know of that maybe should have been talked about, should have been explored?
One of the things that has been on my radar for 40 years has been the failure to follow procedures. And I'm no saint. I mean, there was a period of time in my career I just did the job and didn't necessarily look at the procedures either. I never had any problems. But today, with the complicated airplanes, the number of changes in the basic airplane, so that they're not more now electronic, you can't see leakage of zeros and ones. You need to follow the procedures closely. And in December, this past December, so 6 months ago, I had a conversation with some folks at headquarters in the FAA, and we were talking about current problems in the industry. And the number one problem that they see in the maintenance side of this house is failure to follow procedures. It's 40 years after this American Airlines accident for failure to follow procedures. And we're still having that problem today. Now, we have it in the cockpit too, but failure to follow procedures in maintenance where the procedures are written down and you're supposed to follow them, and we're still having that problem, something's wrong. And something's wrong with our accident investigation because there's not a lot of emphasis. You know, the NTSB, I fought and actually had a lot of people angry with me when I was with the NTSB, trying to push them further into the hangar. Many of the accident reports, and this is one, where they take the accident right up to the hangar doors, and they got all these issues that they've identified on this particular job right at the hangar door, and they don't go in. It's like they write a letter and drop it in the dead letter box on the front door. And that's got to change. They got to change. The NTSB and the FAA has to put the same effort into what goes on the ground in dispatch, in loading, and in maintenance with airplanes that they do on the flight deck. You know, one of the biggest examples I throw out all the time, if you want to change a single word on a flight operations manual, a single word, the process that you have to go through is extensive. But you can rewrite your maintenance manuals and send them to the FAA, and they're just accepted. The FAA never, I know for a fact, they almost never read them because A, they're complicated to read, and B, when you send them to them, we used to send them over in stacks of 10 inches. So we make all the revisions to the maintenance manuals, and then when we had 10 inches of paper, we sent it to the FAA to be approved.
Wow. I will say those are the old days, John, because that's about your era old.
Yeah.
So,
unfortunately, it is true.
Yeah, but you're wise too. That's the benefit of having all of that quote old age, which you're still pretty youthful. It's all that wisdom and you've provided that, I think, in this discussion today. So I hope that our listeners have gained some perspective about this accident. We're going to post up a link on the website so that you can actually pull down the NTSB report. It is an old report. It's archived, but we have a link to pull up a copy of the report if you really want to read the nitty-gritty details about what the board found in its investigation and the recommendations that were made. And again, you can always contact us via our email at flightsafetydetectives@gmail.com. It was an email that prompted us to talk about this accident, and it just so happened to coincide with the 42nd. Is it, John? The 42nd?
Yes, 42 years ago.
Yeah, since this particular accident. And again, it still has relevance today. Again, we had a 777 that just had a major engine problem. It could have been more catastrophic than it was. And again, we could have had an issue where we'd be talking about the loss of an engine. Fortunately, the crew was able to get the airplane back on the ground. So these are the kinds of things that we can look back at these older accidents, because a lot of them in some way, shape, or form still have relevance today. And of course, it's not just issues that develop in the cockpit and the operation of the airplane. In this particular instance, the whole sequence of events for this particular accident started in the maintenance hangar. So thank you, my friend, for walking us through it. I really appreciate it. And of course, we want to thank our sponsors, PAMA and Avemco Insurance, because as John is always telling you,
you want a 5% discount? Call Avemco, tell them you listen to the show, and you'll save yourself some money. And the number is 888-879-0389 or avemco.com. Again, 888-879-0389. You get yourself a discount if you need insurance. Honestly, they are good people to deal with. I don't have any qualms about recommending them because they are good people to deal with. I know several people that have had accidents and were satisfied with what the outcome was.
Well, John, it's always a pleasure when we get to do this show, and we are thankful that we have a great listener base. Please give us a rating on wherever you listen to the podcast through, Spotify, Apple. That's what helps keep us going with this particular show. We greatly appreciate our sponsors, and we definitely appreciate our patrons who contribute to the operations expenses of the show. So thank you to all of you for helping us make this show better. And changes are coming, John. Changes are coming, and I'm getting excited. We're going to have some rollouts of a few new things with the Flight Safety Detective. So I'm really looking forward to this and kicking it up a notch, because we now understand the technology a little better. We have the people that can help us utilize that technology, and we're going to take the show to another level because our listeners have asked us to do that. So we are going to comply.
For sure.
So with that, I'm going to leave you with the last words, as I always do.
And as always, I would plead with everybody out there, if you haven't gotten a shot yet, get signed up and get a shot. Let's get this pandemic behind us. If you're out and about, the mask mandate is coming off in like half the country this coming week. So if you're out and about, you can still wear your mask even though the mask mandate is off. Don't gather indoors with a lot of people. You know, I would still say outside. If there's a lot of people, if there's a small group, that's okay. All right, wash your hands. That's not going to change. In fact, if we get everybody into that habit, the flu season will never be what it used to be.
Yep, that's absolutely correct.
So be safe in your personal life. And if you're going to go flying, please, please, please do a good pre-planning session with your airplane. If something happens on takeoff, make sure you know what you're going to do and where you're going to put the airplane. Do a very thorough pre-flight of your airplane. Touch your airplane. Don't just walk around it. Touch it. Physically move the flight controls with your hands so you can feel if there's something wrong. And if you haven't flown for a while, get somebody who has been flying to fly with you. You know, if you haven't flown for the last year of this pandemic, your skills are much less than what they were. So get somebody to fly with you, refresh those skills before you go sailing off into the wild blue yonder and find yourself in trouble. So please, please fly safely.
To listen to more episodes of the show, go to flightsafetydetectives.com or the Professional Aviation Maintenance Association at PAMA.org, and wherever you find your favorite podcasts. Catch us next time when John Golia and Greg Fife talk about all things aviation. Thanks for listening.